Hello everyone, welcome back to Math Jamboree. In this video, we will have a AP Precalculus type of a question from the topic of polynomial and rational functions. If you are new to channel, please do not forget to hit that subscribe button for more helpful math tutorials. Today we're diving into the solving of polynomial functions. We're going to break down each step so you can master solving this type of problems. Ready? Let's get started. Here is the problem of the polynomial function. A polynomial function p of x is given by p of x equals x plus 1 times x minus 3 times x minus 2. What are all intervals on which p of x is greater than or equal to 0? Our goal is to find all intervals where p of x is greater than or equal to. So greater than or equal to meaning, so this section is important, greater than or equal to, so we want to determine where this polynomial is greater than or equal to 0. Let's begin by finding the roots of the polynomial. The roots are of the polynomial. To find the roots of the polynomial, we will just set each factor equal to 0. So let's do that over here. X plus 1 is equals to 0. This gives us x as negative 1. And x minus 3 equals 0. Then x is positive 3. And x minus 2 equals 0, x equals positive 2. So now the roots are the polynomial. So we have three roots, x equals negative 1, 3, and 2. These are the points where the polynomial equals 0. We will include these points because it's greater than or equal to. Now we need to analyze the sign of the p of x in the intervals formed by these roots. These roots divide the real number line into 4 intervals. Let me show you the intervals over here in this case. So we will just put them in here. And from left to right, negative 1 comes first, and 2, and the positive 3. So now we will pick test points for each interval, and then we will determine whether p of x is positive or negative in these regions. Let's start with, and the left to right, I'm gonna start with between negative infinity and negative 1. If we will just pick any number, we can just less than negative 1, we can go with negative 2. So then p of negative 2, I'm gonna use a different color pen for this section. P of negative 2 is equals to negative 2 plus 1, negative 2 minus 3, and negative 2 minus 2. And this will becomes negative 1, negative 5, and negative 4. If you will multiply all these three together, because all it's negative 20, you don't need the value actually, you're looking for the sign. If you will see three negatives, you can go ahead and say that the value of p of x is negative in this interval. So after negative 1, between negative 1 and positive 2, let's determine another value for x. Let's go with 0. It's easy to substitute. If you will just put 0 for the x, this becomes 0 plus 1, 0 minus 3, and 0 minus 2. And just if you will multiply 1 times negative 3, negative 2, it's positive 6. So the p of x is positive in this interval. Between 2 and 3, we can substitute the value, and For instance, 2.5. If I will put 2.5 for x, this becomes 2.5 plus 1. 2.5 minus 3. 2.5 minus 2. And this will become 3.5 times 2. This will become negative 0.5 times it by and 0.5. You don't have to calculate this. You can just look for the sign. Positive times negative is negative. Negative times positive is negative. The answer is negative something. But if you will just go ahead and calculate them, this will give you 0.875. So between 2 and 3, the R function P of fx is negative in this interval. So after 3, we can use a value. We can use, let's use 4 for it. So now we're going to substitute 4 for the x. This becomes 4 plus 1. 4 minus 3. And 4 minus 2. And if you will just substitute these, 5 times 1 times 2, that gives you positive 10. So P of x is positive in this interval then. This is positive. So we were looking for positive intervals. We found here and here. How are we going to determine these? So since we're looking for positive, so let's write these as the solution from between negative 1 and 2. Are we going to include negative 1 and 2? Yes, because it's greater than or equal to negative 1 and 2. And these will be included. Union with 3. Are we going to include 3? Yes, because it's the root and it says greater than or equal to. If this could have said just greater than, you don't include 3 then. And positive infinity. If you will look at the choices, choice A is not the answer. Choice B, negative infinity, negative 1, no. Choice C, negative 1 to 2 in union with 3, included 3 and positive infinity. This is what we're looking for actually. And the choice D is not the answer. So the choice C will be the correct answer for this specific question. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Good luck with your studies. See you next time. Bye-bye.